right, so today we are going to be completing lesson 29-1. This is on page 445. If you don't have your book with you, then you need to get out a sheet of paper to write these things that we're talking about down. So in our last lesson, we talked about how to graph the parent rational function, and we talked about how rational functions have a variable in the denominator. So here we have rational expressions. Now, remember that expressions do not have an equal sign, and nothing you see in today's examples that we're going to do or in the homework for tonight is going to have an equal sign in the original problem. We are simply going to be simplifying, multiplying, dividing. We are not solving an equation in this case. It is really important to note that we do have to do a restriction. We talked about restrictions when we did inverses, in that we had to restrict the inverse to make sure that it matched up with the original. Here we have a different type of restriction, and that's what's in this math tip box right here. So put a big star here, because along with our simplification, we're going to have to list restrictions for every single problem. And the variable in the rational function has to be restricted so that the denominator will not equal 0. So basically this paragraph right here is telling you exactly what we're going to do. If we want to simplify a rational expression, we are first going to factor the numerator and the denominator. So we're going to factor everything. Then we're going to identify restrictions. So meaning we're going to see what would make our denominator 0, and we state those restrictions. Then it says divide out common factors. This means that we're going to reduce. So we're going to write those things out here on the next page. So turn to page 446. And we're going to write out those steps right over here by try these A. So steps to simplify. Our first step is going to be to factor denominators and the numerator. So we're going to factor everything. Then we are going to identify restrictions. And remember, that means x can't make the denominator 0. And then finally, in step 3, we're going to reduce common factors. Okay. So for our first example here, we are going to look at, try these A, part B. And so for this, our first step, factor the denominator and the numerator. So it doesn't matter which one you factor first. If you need to review factoring, I've still got those videos posted, but at this point you really should know how to factor. There is no GCF on the top. It's not a special product. So that means I'm looking to chart factor it. So I'm looking for what multiplies to negative 15 and adds to negative 2. So multiplies to negative 15, adds to negative 2. So the winners here would be negative 5, positive 3. So that means this top factors into x minus 5 times x plus 3. So I'm done factoring my numerator. Now I need to look at my denominator. Again, there is no GCF here. So that means that I move on to the next step, which would be special products. This I know can't be a special product because 2 doesn't have a perfect square root. So this again is going to be chart factoring. Now, the coefficient is not 1, so it's not the same type of chart factoring. It's either the guess and check or the slide divide bottoms up. Because it's just a 2, I am definitely going to guess and check because the only possibilities for the fronts are 2x and x, no other possible way for it to factor. So I am going to guess and check with the factors of -9 until I can get a +3 in the middle. So remember that most of the time it's going to end up being the factors that are closer together. So for 9, the only choices are the 1 with the 9, versus plus and minus, and 3 and 3. So I'm going to try the 3 and the 3. So if I do that, I'm going to get 6 on the outside and 3 on the inside. So I want the bigger number to be positive. So I'm going to make this a plus, and I'm going to make this a minus. And so now I get positive 6x minus 3x, which is 3x. So this is now factored. So step 1 is done. Step 2 is to identify our restrictions. So basically we need to identify what's going to make our denominator 0. In order to do that, we just have to see what would make these factors in the denominator equal to 0. So if 2x minus 3 equals 0, that would be bad. So add 3 here. And so that tells us that 3/2 would make my denominator 0. So I basically change it from an equal to a not equal. And this is my first restriction. X cannot equal 3/2. So then I look at the other factor, which is x plus 3, and I tell myself, well, that can't equal 0 either. So x plus 3 not equal to 0. Subtract 3 on both sides. That means x can't equal -3. So I have 2 restrictions. X can't be 3/2 and x can't be -3. So that's step 2. It's done. Step 3 is to reduce any common factors. So here I do have a set of common factors, x plus 3 and x plus 3, one in the numerator, one in the denominator, which means they're going to cancel each other out. So I then, when I simplify, have x minus 5 over 2x minus 3 as my simplified expression. As I said kind of in the intro, those restrictions are part of your answer. So every answer in your homework is going to have some restrictions. And we just put that with our final answer here. All right, we're going to do one more of this type. Try these A part C. So same 3 steps. I'm going to factor first. When I look at the numerator, there is a common factor of x. So I'm going to take that out in front. That leaves me with x squared minus 9. My denominator, it doesn't have a common factor, and I noticed that it's linear. Normally, we wouldn't do anything if the denominator is linear, but in this case, my x comes second, and we really need it to come first. So what we do is we multiply by -1 so that we can switch the order, so that then I can make this x minus 3. So -1 is a common factor, and the x needs to come first. Otherwise, it makes it very difficult to see what to reduce. Now, unlike in my first example here, this is not fully factored. I did a step of factoring, but I'm not done. X squared minus 9 is a difference of squares. So I need to factor that further. X squared minus 9 factors into x plus 3 times x minus 3. Okay, then I look at my restrictions, and because I only have one factor with a variable in the denominator, that's the only restriction I need to worry about. So I know that x minus 3 cannot equal 0. which means x cannot equal 3, which makes sense. If x was 3, 3 minus 3 gives me 0, and we know that's not allowed. So then I'm going to reduce common factors. I've got an x minus 3 down here and an x minus 3 up here. So those are going to go away. I've got x times x plus 3 left in the top. I've got this negative 1 left in the bottom. We don't leave denominators of 1. So this dividing by negative 1 is just going to change the sign. So we make this x that was in front negative. And then this is our answer with the restriction x cannot equal 3. Sorry, that not equal sign is kind of sloppy. But that's our answer there. Okay, hopefully that doesn't seem too tough. The next thing that we have are when it's not just a single rational expression that we're simplifying, but we have multiplication or division of two separate rational expressions. The only thing that we're going to do differently for those is that we are going to in between step 2 and step 3, before we reduce common factors, we insert the step where we need to multiply or divide. So, scroll down here. And look at these ones. So, steps again here. Steps to multiply or divide. First, we're going to factor everything. All the numerators, all the denominators. Then we're going to identify restrictions. One little thing that gets a little bit confusing sometimes, if it's a division problem, we also have to restrict the second numerator. The reason why is, remember that when we divide fractions, we multiply by the reciprocal. So what was the numerator becomes the denominator, and it doesn't matter what step we're in, we're never allowed to have 0 in the denominator of a fraction. So we can't have 0 in the original denominator, and we can't have 0 in what becomes the denominator when we flip it. So you'll see, because I'm going to do 2 examples of this, so you'll get to see that. Step 3, you are going to perform the operation. So meaning you're going to multiply, or you're going to flip, perform operator, not operator, operation. There we go, sorry. So if it's multiplication, you're just going to do top times top, bottom times bottom. If it is division, then you're going to flip the second fraction and then do top times top, bottom times bottom. Once you've done that, then we will reduce the common factors. So very similar to what we did in those first 2 examples. So we're going to look at, try these B and C. So in A here, first thing I need to do is factor everything. So my first numerator, there's a GCF of 2. So 2 times x plus 2. My first denominator, x squared minus 25, is a difference of squares. So I'll make that x plus 5 times x minus 5. Second numerator, there is no GCF. It's not a special product. So this is chart factoring. So looking for what multiplies to negative 50 and adds to negative 5. So let's see, negative 10, positive 5 would add to negative 5. So those would be our winners. So it's going to be x minus 10 times x plus 5. Second denominator, there's a GCF first of 4. When I pull that 4 out, I get x squared minus 4. And then this guy is in itself a difference of squares, so I will factor it further into x plus 2 times x minus 2. So final factorization looks like this. All right, now I need to look at the restrictions. So I know that none of these 4 things can equal 0. So I wrote it out for you in the first few to give you the idea of what was happening. I would think that most of you can just look at it and write out the restriction. If x plus 5 can't equal 0, that means x can't be negative 5. This tells me that x can't be positive 5, so x can't be plus or minus 5. Down here, that means x can't be plus or minus 2. All right, restrictions. And it's not division, so we don't need to worry about the second numerator. Then we perform the operation. Now, with multiplication, it's just top times top and bottom times bottom, which means that performing the operation just means like writing it all as one fraction. So meaning we have 2x plus 2, x minus 10, x plus 5. And then in the denominator, I've got this 4 in front, and then I've got x plus 5, I've got x minus 5. Sorry, my x didn't come out real great there. X plus 2 and x minus 2. So that's my operation. Now I'm going to reduce the common factors. So x plus 2 cancels with this x plus 2. This x plus 5 cancels with that x plus 5. The 2 and the 4 also reduce. 2 goes into 4 twice, so this becomes a 2, and that cancels. So that means all I've got left is an x minus 10 in the numerator. And in my denominator, I've got the 2, an x minus 5, and an x minus 2. And just like we decided with our restrictions, x cannot equal plus or minus 5 or plus or minus 2. And that's our answer there. Okay. Let me switch colors here so that they don't all run into each other. Here, we're going to try this B, but I'm going to put it down here since I don't have a lot of room left there. My first numerator can't be factored because it's a monomial, so I can leave it as is, 6x squared. In the denominator, I first have a GCF of 3. If I take that out, it gives me x squared minus 9, which hopefully you recognize as a difference of squares. So that gives me x plus 3 and x minus 3. Then my second fraction, the numerator has a GCF of 2, so factor that out. In the denominator, it doesn't have a GCF. It's not a special product, so I'm looking for what multiplies to negative 3 and adds to negative 2, which would be x minus 3 times x plus 1. All right, fully factored. So now I'm going to identify my restrictions. So I know from this denominator that x cannot equal both plus and minus 3. Over here, x can't equal 3, but I've already listed that, so I don't need to list it again. I also see that x cannot equal negative 1 there. Because this is a division problem, you also have to look at restrictions from the numerator of the second fraction, which would be this. In this case, I don't have any new factors that I didn't already have in the denominator, so I don't have to add anything, but I do need to look at it. So nothing to add. I can go ahead now and I'm going to perform the operation, which means that since the operation is division, the first thing I need to do is flip the second fraction. So the x minus 3 times x plus 1 goes on the top. The 2 times x plus 1 goes to the bottom. And then top times top, bottom times bottom. So on the top, I've got 6x squared in front. Then I've got an x minus 3 and an x plus 1. In the bottom, I've got 3 times 2, which is 6. And then I've got x plus 3, x minus 3, and x plus 1. Then I'm going to reduce my common factors. The 6 and the 6 cancel. The x minus 3's cancel. And the x plus 1's cancel. So I simply end up with x squared over x plus 3, where x cannot equal both positive and negative 3 and negative 1. All right. Final example for the lesson, we are going to look at this number 5 in the Check Your Understanding. And I would like for you, because I already showed you an example of division, and as you've noticed, these examples that we've done, gradually adding steps, the division ones require the most work. So if you can do the division problems, you should be able to do the multiplication and the simplifying problems. So I want you to go ahead and give this one a try on your own to make sure that you know what you're doing. So pause the video. Go ahead and try working all 4 of these steps with this, and then unpause it to come back and see my solution to check your work. All right, so step 1, you were to factor everything. So first numerator is a difference of squares. X plus 5 times x minus 5. Bottom is chart factoring, the numbers that add to or multiply to negative 7 and add to positive 6 would be x plus 7 and x minus 1. My second fraction, the numerator is also a chart factoring. The numbers that multiply to 40 and add to 13 are 8 and 5, so x plus 8, x plus 5. In the denominator, also chart factoring, looking for what multiplies to negative 8 and adds to positive 7, which would be x plus 8, x minus 1. So that's my first step. Step 2, you should have identified restrictions. So down here, first denominator, x cannot equal. This would be negative 7. This would be positive 1. Over here, positive 1's already there. I don't need to add that. This adds negative 8. And then I also, because it's division, need to restrict in the second numerator. So negative 8 is already listed, but negative 5 is not. So I need to add that to my restriction list. All right, step 2 done. Step 3, perform the operation. So I'm going to change this from written division to multiplication by the reciprocal. So what was in the numerator is now going to the denominator. What was in the denominator is going to the numerator. And then I can multiply top times top, bottom times bottom. So x plus 5, x minus 5, x plus 8, x minus 1 are all in the top. And in the bottom, x plus 7, x minus 1, x plus 8, x plus 5. So then I reduce my common factors, x plus 5 in both places, x minus 1 in both places, x plus 8 in both places. So look at all that go. And so I end up with x minus 5 over x plus 7 with the restrictions that x cannot be. I'm going to list them in order: negative 8, negative 7, negative 5, and positive 1. All right. Hopefully you did well and that makes sense. Homework problems are the practice, which is on page 448, numbers 6 through 11.